Welcome, everyone, to another episode of Cloud Chat with Stephan and Matt. I'm one of your hosts, Stephan Stelter, and I'm joined by your other host,
Matt Brown. Very nice to see you or talk to you or whatever we're doing here.
Indeed. And we have a special guest with us today. Welcome.
Very special guest.
We're happy to have you with us on the Cloud Chat. Can you tell us a little bit about what you do at NetApp?
So I'm Scott Stanford. I work on the platform side within IT, so it's more of the Kubernetes level and doing automation around it, so that the application teams can come in and just kind of consume Kubernetes as a resource versus having to worry about the administrative aspects or access around it.
What a wonderful topic. So Stephan, how often does this conversation about Kubernetes come up in the partner space?
Yeah, what's fascinating to me is this is a bit of a cross-pollination, cross-promotion conversation for me. We are doing some coffee break sessions with some of our partners this week, and we're talking with Jason Benedicic about our capabilities as a company, NetApp, from a product and service capabilities perspective around Kubernetes. And there were a bunch of things that I didn't know in that context that I've learned from Jason, and they were surprising to me. So partners are hearing more and more about it, but there was a lot in that conversation that I found interesting. And I'm excited to bounce some of those thoughts off of Scott to see how that aligns to his view.
Excellent. And Scott, just so you know, as you know, my job is to talk with customers. It's probably one of the hottest topics out there. And what they, kind of like what you're doing, they want to know how even to start sometimes, or what's the benefits, and how do you develop a practice in what would be considered a company that started in our data center, and lots of legacy applications. Why are you doing this? Why is it important? And, really like to hear your views as a person who actually does it. So before we get there though, Scott, so Stephan, you had said that you wanted to kind of maybe start it with a few questions. Let's do that.
Yeah, well, I think one of the eye-opening moments for me in conversation was the idea that when you think about containers or Kubernetes in general, you start thinking about, well, that must be for organizations that have developers and are writing their own code, and that's the only place containers happen. It's when people want to open source things. And my organization is, we make widgets, we stamp locking fasteners or something. We don't write code. We don't have developers. And so that is one of the things that gets conjured. But I think one of the shifts for me was this idea that you might be running containers and not even know it. And one of the very concrete examples for me there was this idea that vCenter Server is packaged as a collection of containers today, and not as an application that runs on a Linux framework or something like that, where it's a native app running on an OS directly. It's a collection of containers. So that to me was like, oh my gosh! So people are running containers that don't even know that they're running containers, and the implications of that I find interesting as well. We're going to need to make sure we understand that as IT organizations that don't have huge development teams. You're going to be buying off-the-shelf software that is effectively deploying containers. How do you treat that? What do you do in your environment? So that was one of the eye-opening moments for me.
We also consume them every day too. I mean, look at Amazon.com. That's all container based. So I mean, you go shopping, you're hitting containers for the websites.
You bet. So, you're interacting with them on the regular, for sure.
So Scott, let's talk a little bit about that. So why? I mean, are we doing this for technology's sake? I'm sure there's a great why there. So why do you think people are modernizing their applications in this way?
You get better reuse of resources. I mean, we kind of evolved from having the physical machines and data centers to having virtualization, which we were able to over provision the hardware in the virtualization environment. This kind of takes it a step farther, because with the virtualization, you're talking about how many CPUs and how much memory to give a VM. Well, in containers, you're talking, down to the millicore, and as far as CPUs that you're giving a container. Plus, it has native HA built into it. So as long as you're deploying with replicas, you set things a certain way, you can have whatever you're running in Kubernetes run across multiple worker nodes. So if one of those nodes goes down, you probably won't even notice, because The other two are, if you have 3 replicas, the other 2 are running, and Kubernetes isn't going to wait for that node to come back up or figure out what happened. It's going to start that pod up on one of the other worker nodes that's available in the cluster. So you get some cool things like that. You get services which act like a load balancer within the cluster. You can develop at a smaller component level within your application instead of having this big monolithic, we all got to line up. Let's say you have a huge application. We all have to line up to this date, to be able to release, where containers, you're broken down into smaller components of the application. So each individual application team can do releases in their own cycle and not have to wait for the other teams to be on that same page. I mean, there's probably cases where they need to, but by and large, they tend to be more independent with that scheme.
Yeah, that breaking down the workload into smaller chunks or the problem in general just aligns well with my brain. It harkens back to schooling for me and the how do I solve this problem that seems overwhelming? Well, what do I know about this problem, and how can I break it down into smaller groups, and then further subdivide? And just thinking about that in that context of, instead of having this huge application. And we think about how we used to do this, where you'd have the web tier that was interacting with the end user, and then there was an application layer, and there's some business logic, and you're layering all these things together, and just trying to get the whole thing working properly is
and even maintaining a reasonable uptime and performance and stuff. It makes your head hurt how much exercise that was, right?
Yes, and then all of a sudden your demand doubles. What do you do? And that is just it's not a trivial problem, because you're architecting for a certain thing with the way that you're building your web, your middleware, your application layers, your backend databases. You're kind of sizing to peak in a sense. How do you do this when suddenly it goes well beyond that? And does it cripple the whole thing? Right. So it seems that there's a whole lot more flexibility, as I understand it.
Yeah, and even from like an IT standpoint, so the evolution from physical to VMs. Well, Kubernetes can run on top of the VM. So if you have that model, you're over provisioning your VMs, and then you're running Kubernetes on top of it, which you're taking a pie and slicing, and then you're slicing a little bit more, so you can control things a lot more. And depending on your workloads, you could be over provisioning in 2 different areas.
Interesting. And you had mentioned HA, because I'm my background a little bit was designing environments and stuff, and HA was obviously a very important part. But the HA you're describing is kind of a dynamic HA, and if I could I argue, if you could run it between data centers, actually have business continuity. It really.
So depending on the nature of the application, you can do that. If you think like a web server, it's a simple case, like an Apache web server. Yeah, you can run that in multiple data centers, and then just either have some type of way to get the data that's being shared, or being presented in the web server, make that available at the other site. That's the easiest scenario. It gets a little bit harder when you start talking about databases within Kubernetes, because now you have to, it's a lot more involved. You can do it. It's just you have to worry about latency and connectivity and some stuff like that.
Now, in your words, so why did we in NetApp IT take this direction? What was the driving factors, and what did you see as those driving factors?
I think it was probably two big things: to reduce our footprints and make it a little more flexible and agile as far as what we can do. Because if you're looking at VMs, typically VMware is the big dog, right? Yeah, and if you want to move a VM from one site to another, it's a bit of work. Where if you have a cluster, Kubernetes cluster, the cluster is the same. It's just what's deployed that's different. So you can just, if you deploy in cluster A, depending on what the dependencies are, you can define in cluster B, and should work. The other thing was we're creating a platform for our application teams to be able to quickly use and be agile on the development side, so they didn't have to worry about maintaining VMs or patching VMs, or they're completely abstracted from the OS layer. They're just focused on what they're running in Kubernetes, nothing else.
This conversation reminds me of a couple of other interesting items that surfaced. One of them is in my brain to help me get from a VMware environment to a containers Kubernetes environment. I would draw some parallels between things, and try to think about, okay, a container is analogous to a VM and Kubernetes is analogous to a vCenter server. And those help my brain as some crutches in a way. Clearly we're pulling things apart. We don't have the OS, the burden of the OS that we have in a VM. That burden goes away in a container, and it's more having the right collection of libraries and being able to call them with the container. But then there was another item that surfaced as a parallel where you could think of a container as almost like the MSI installer for a Windows environment or an RPM in a Linux environment. It is the way to package an application, and it has more of an analogy to MSIs and RPMs than it does to virtual machines in some context. So I was curious what your reaction is to that thought and that analogy.
Yeah, so from a Linux standpoint, I would almost look at it from like a system daemon perspective. So again, Apache is it's an RPM or multiple RPMs to run, but ultimately it's running on the operating system as a daemon. So if you were to take all that together, you'd run that in Kubernetes, and so you'd put that into an image, and then you'd have a replica of those pods. So now get your HA pretty easily.
Okay, got it. Yeah, I think that helps distinguish some of the pieces. So in the context of software development and quick turns and quick cycles, the idea of treating it like an RPM or using that as an analogy is useful because it's we're delivering an application, we're delivering a capability in a more convenient package than a virtual machine. It's a lighter package, but it shouldn't be confused with RPMs in general. In the idea that maybe there's. I think about dependencies in RPMs. I think about some of the work that I've done in Linux over time, and you think about, well, I wanted to deploy this one application, but I couldn't deploy the RPM because I didn't have the right version of these 15 other different RPMs and the right architecture. And it seemed like, well, Linux is easy and it's going to be great, and it just felt like I was spending hours and hours and hours getting the right packages that were hopefully compatible with the right object files from the right versions of the right kernel. That was not fun. Does some of that go away then in container land because it's you can think of it more like a daemon and things are packaged together a little cleaner? Or
so I mean I think what you're talking about is like years ago with Linux when it was really painful.
Yes,
it's gotten a lot easier now, but so you did kind of work. It's easier with Kubernetes. So let's say you're creating an image and you're using Docker. You have a file that kind of builds, it has those dependencies in it, and whatever files or tweaks you want to make, you're really just building that image, like almost like building a VMDK, but it's much smaller and focused. And once you have that image, you can run it locally. If you have Docker installed, you can deploy it into Kubernetes. You really have some options there, but you're building it. And once you build it, you're working through all that stuff. And if you're using Docker, you can pull in images you can do sub packages. So let's say if I was doing something with Python, I could pull in a Python image, and then based on that, I could tweak it some more instead of having to go through and start from scratch. And here's a bare bones, Linux image that you got to install this and install that. So it definitely makes it a lot easier. And again, once you build it, it's not like the whole team is necessarily building things. You probably have it in a pipeline or something. So you check in your code, you push it, gets built, and it's happening on the back end. And once you have it figured out, you only have to look at it when there's an error.
got it.
So, a question for you. It sounds, I see why everybody wants this. The whole HA and the potential options for, if you design your applications right for business continuity, which kind of gets me to that designing that applications. Do developers have to do something different to leverage this type of an environment? I mean, do they have to adopt different practices? I mean, do you have to have both developers and the infrastructure teams making this change to make this work?
Yeah, I mean, once the infrastructure is there, I mean, developers can just consume it. They don't need to even really worry about the infrastructure too much. Depending on the application. So if you have a legacy application or monolithic application, you have to go through some pain to break it up and figure out how to break it up into pieces. And it takes some work to get there.
That's that whole microservices conversation that we have with the developers. Yes.
But I mean, there are technologies out there that make it easier. There's API gateways. So, again, let's go back to the Amazon example. You hit different paths on their website. There's really a different containers that get run at different times. So you think you're shopping, you hit one type of container, you go to hit the checkout or look at your cart, you're hitting this other container. It's all just based on what path you have in the website that you're hitting. So there's technologies like that developers can consume within their application at different levels, which make it easier. And once you figure out hard part's figuring out how to break things up and do it in a scalable way that's easy to maintain.
Excellent.
Yeah, I love the Amazon example. There's so many elements to Amazon.com as a web page that help you see paths that can be different and simultaneous and through different containers. Like people who bought or are looking at what you're looking at also bought these things, right? So you get to see those adjacent pieces and finding those images, loading those images. Those don't need to be done by the one Apache instance that's running www.amazon.com. Right? There's a whole bunch of little containers feeding into that. And I also appreciate the idea that, hey, not everybody on the planet is Amazon.com. Does it matter for smaller organizations? And I know one of my favorite examples is one that we've discussed in the past at our support site inside of NetApp. And knowing a bit about NetApp and the backend systems, seeing how different elements of my support.netapp.com, how they get populated as you choose different menu items, and you can start to see, oh, those are fed by different containers. You can almost feel that happening.
The support side is, I'm not familiar with the architecture. I just know bits and pieces of it, but it's, from the Kubernetes standpoint, it's broken down into different subcomponents that they deploy in Kubernetes, and I think they might cross different namespaces, but there's quite a bit there that they're running, and it's really cool and really big.
Yeah, well, and I, instead of me kind of talking about the benefits, can you kind of share what the benefits are? So Support Site's a great example. So Support Site was here before I even got here 22 years ago, and it's been just cobbled together. And we would literally have a downtime maybe once a quarter to make the most minor changes. And when you take it down, you also have to take SAP down, our CRM, right? So can you kind of talk about some of the benefits of, we'll use Support Site as an example.
Sure. So if you exclude the other dependencies that it has, like CRM, right, things that outside of Kubernetes. So for the Support Site, they use Mongo for most of their database, and they have a standby instance running in another cluster. So they keep that fairly up to date, for a failover. So if our primary cluster, whatever, connectivity, something bad happens, that cluster goes down, they have everything checked in as far as how to deploy it. And all they have to do is increase that Mongo database that's in the other cluster, and then just deploy their stuff over there, and they're up and going. I mean, they're in some DNS changes, but I mean, it's not like we have VMs and you have to, that's a whole lot more work. This makes it a lot simpler. So I mean,
even with something like Site Recovery Manager, you're not waiting for the VMs to come up and make sure that they're doing the things that they need to do properly before turning the users and pointing the users at it. Is that, I'm trying to imagine an SRM parallel where VMware Site Recovery Manager is making things more automated. Is it just, it's simpler because it's smaller and lighter in the things that need to be moved and brought up?
So it is simpler and lighter. If you look at so if you look at VMware, if you're trying to do the SRM, for example, whatever capacity you have at your primary site, you have to have at least that capacity in your secondary site, plus whatever you're running there. With Kubernetes, it's a lot smaller. I mean, you're not talking, full CPUs, potentially your millicores. I mean, it's just a smaller footprint, and we're using a combination of on-prem and AWS. So if our DR site is AWS, we don't care about the compute because we can scale.
Yeah.
So that covers that. Plus we're, multiple different groups are running on the same worker nodes. They don't know it. They can't see the others. They just see what they have access to, which is their namespaces.
And this allows me to make changes to the support site with actually really not even taking the site down, right? I can make
Yep. So that they can make changes because you can do a rolling update with your deployments in Kubernetes. So, a certain percentage, you can do blue, green. And we've had issues where we've had stuff happen in our primary cluster. Support sites moved over into the DR site, and it wasn't. You spent more time talking about, well, when's the primary site can be fixed? Do we need to go through moving to the DR site? I mean, those conversations tended to last longer than the support site team actually making the move and getting things up and running.
That's very interesting. Like, I mean, in the example of Amazon and now the example of support site, you kind of get through implication that it's kind of the de facto state of modern architecture to give that flexibility. If Amazon's running on that and they have to be always on and always changing, it sounds like that is the model you want, the architecture you want.
Yeah, you want to be able to do updates without traditionally when you do an update to an application, you got to have, like you said earlier, Matt, some type of downtime where you got to, have that transition because, maybe you have 20 VMs that it's using and all the application has to be the same on all of them because it's a bigger application. With Kubernetes, you tend to have different APIs, different versions of APIs. So you make your application scalable just by checking the API version that's, so it's always backward compatible. And then you can do a rolling update of your deployment. And, now you're running the latest and greatest. And if you have to roll back, you can do the same thing.
Well, it's funny too, because, one of the things that has been very clear to me is the world has changed quite a bit from when I was doing delivery. Demand, people were used to getting stuff in weeks. And can you imagine our world now, people waiting weeks to get stuff? I mean, it just sounds unheard of, right? And it sounds like, again, this really enables that faster turn. I have a set of questions, but Stephan, I wanted to see if you
keep going. I am enjoying the.
Well, so here's I think a real world challenge. So I'm sure we have people listening, and I know when I talk to customers, people are dying to move to this type of a platform, and a lot of people are experimenting and stuff. Since you are on your journey, is there anything you could suggest that maybe somebody doing this who's just getting into it, what are some great places to start, or how did you start even doing this here at NetApp IT?
So for me, I changed teams, and the team I moved into, on Kubernetes. So I didn't really know much about Kubernetes before that. Did a little bit with Docker, but it's the terminology is different. There's no mapping of like a virtual center to Kubernetes. I mean, we think like a virtual center because that's what we've used for years. And so you get these different terms, pods, namespaces, replicas, daemon sets. It gets really confusing really fast. So you got to get in there. You got to play around with it. You test cluster, just deploy some stuff, find stuff online you can deploy. What helped me is I actually created my own image and deployed it for some data collection that we're using. So I got to do the flip side of it, and I understood a bit more. And I also have a home cluster that I'm using, which filled in some of the gaps because there's no one's going to swoop in and save me and help me get this stood up. So I got to do it all myself.
Is there something, if you had a friend at another company right now and they were just starting off, is there one or two things you would suggest for them to do to maybe avoid a pitfall that you've encountered?
It's usually, starting out using one of the hyperscalers, the Kubernetes as a service and a hyperscaler makes it a lot easier because you don't have to worry about the control plane. And that tends to be a stumbling block when you're first starting out. So once you have the control plane up, you're just focused on deploying stuff to it. You're not worried about etcd or things like that. So and that definitely makes it a bit easier. And in our environments, we're using Spot.io Ocean a lot. So that's a layer on top of it, on top of the hyperscaler Kubernetes service, which handles the scaling, some other stuff for you, which even makes it even easier. You don't have to worry about the compute side. You're even more focused on just the consumption.
And it even saves you money in doing so.
Saves you money. Yep.
Excellent. And from at least to close on my line of questioning then, so that's great day one stuff. What about supportability? So you have these applications like our support site running. Are there things to consider, things that you've learned that, if you're going to do this again, here's one or two things that in running day 2, here's what I would do different, or what we're doing now that we've learned from our experience so far.
So I'd say automation is key, and it's not just even going out and doing automation. I mean, you need to think ahead of, when operations comes in and does some aspects of the management of the clusters once it's done. Yeah, so a good example is, in the fall, we were using AWS with Ocean. We had a couple clusters. We didn't think it was going to grow that much. So we did it a certain way. We used a modified EKS CTL to deploy it. It was great. Do updates. It was just a lot of, clicky stuff to do updates, pretty simple. Change an AMI, tell it to roll, easy. So we had a little change in direction around February, and now we're around a dozen clusters, and how we deployed those clusters was the same as we did before, so we're consistent. But now it gets into this whole headache around operations with it, because we've been moving to some of our automation to Terraform, and you can't just point Terraform at something that's already deployed, because it wants to own whatever's being deployed. So its first thing it would do would be delete the cluster and then reprovision it, which would cause some headaches. So, trying to work through some of that. If we had deployed originally with Terraform, it would have made our lives a little bit easier. So we're kind of working around that. We're handling things at a virtual node group level in Terraform versus the whole cluster, which gets us by for the most part, but it does have some challenges with it.
Interesting.
Scott, this has been an amazing conversation. I really enjoyed it. I enjoyed especially just building up some of the conversation around the basics of Kubernetes and containers, and drawing some parallels together, and then helping us understand some of the real world use cases and some of the pitfalls that you encountered in day 1 and also into the day 2 and on. So thanks so much for sharing. We'd like to reserve the right to bring you back to
most
cloud
definitely.
chat with Stephan and Matt.
Well, and again, to answer the basic question, it sounds like this is the direction we all should be heading on for modernizing our applications. So Scott, very, very valuable for us, and hopefully our listeners will also find value here. And, to put it in a quick plug, this is what NetApp is all about. So if you want to talk to us more about our own experience here, please reach out. We look forward to talking with you. So Stephan, do you want to close us out?
If you enjoyed this session, please subscribe, hit the bell, do all of the fun things that indicate that you enjoyed it. We'd love to interact with you in the comments of the video as well, if you happen to be watching this.
Comment.
Yes, comment. Thanks for listening. Thanks for tuning in, and we'll catch you on the next one.
Thank you.
Thanks so much.